Okay, let's go ahead and take a look at problem 9.2.19. In order to construct a confidence interval in any of these situations for means, we need to remind ourselves of the formulas here. A confidence interval is just a lower bound and an upper bound. We need to calculate those two numbers. In order to do that, we need these values. The point estimate, which is given here, 19.2. You need the standard deviation, which is going to be 4.7. We need the sample size on this first problem is 34. And so then with those numbers, we can then calculate the critical t value. T alpha over 2, alpha is 0.05 because this is a 95% confidence interval. Since we're doing a critical t, not a z, we need to use a t calculator, or you could use the t table also, but I'm going to use the t calculator. In this case, we had 33 degrees of freedom, and I think your alpha over 2 is 0.025. Compute that, and so our critical t is going to be 2.035. If we're going to round it to 3 decimal places, 2.035 is what we will use right here. So this is 2.305. And so now that's the number that would go into this equation here, which I've already pre-written out. And so this number here, right, is what's going to go into these locations here. Let's squeeze that in, and so this is 2.305, 2.305. And so when you plug those numbers into this equation here, you end up with 17.342 as the lower bound, 21.058 as the upper bound. These are 2 decimal places, so this would be 34 and 06. And so those are your upper bound and lower bound. And so that's how you calculate it. We could also use Statcrunch to do that. I want to show you that real quick. This is T-stats. We have one sample. We have summary data here. You would put the mean, 19.2, standard deviation is 4.7, standard sample size, and then we're doing a 95% confidence interval. Compute, and so you can see we end up with lower bounds, 17.56. What did we do wrong here? 19.2, 40.7. There we go. And so Statcrunch gives you an answer, and it's a good way to check. I noticed that I have a typo. I put it's 2.035, and if you notice, so this is the correct answer here using Statcrunch. And then here, notice that I did put the wrong answer here. So it's not 2.305. It's not 2.305. We end up having to plug in, we should be plugging in 2.035 in here. And so that's what should go in here. And so when you put 0.035, 2.035, we don't end up with those numbers. We end up with 17.56 and 20.84, which is, again, then the answer that we get from Statcrunch. So that's how you could check your answers there. And that's how you would find the confidence interval. And now notice, again, we would do this again, but n is 51. So everything would be the same except put a 51 here. And then you're going to have to then, because the sample size changes, you get a new critical value for those for this situation here. And what we're trying to learn is what happens to your margin of error. How does increasing your sample size affect your margin of error? And so there is an important idea that there's a relationship between sample size, margin of error, levels of confidence that this problem is taking you through. And so you want to refer to your notes here to answer those questions. And what we learn from your notes in 9.1 is that the margin of error depends on 3 factors. Your level of confidence. As your level of confidence increases, your margin of error also increases. You have to make more room for error. If you want to be more confident with your answer, sounds contradictory, but that's the situation. Sample size increases, the margin of error decreases. So as you increase your sample size, you're more sure with your answer. And so standard deviation of the population, the more spread there is, the wider our interval will be for our level of confidence, or there'll be more margin of error.